So, good morning, everyone. So today we are discussing the very important topics. So in this, the first thing is we have to cover is that network graph. Okay. So in this chapter we have to discuss about the concept of the network graph and the matrices associated with the graph, namely the incidence, fundamental and cut set, and the fundamental circuit matrices. Okay. And the first topic is that the network graph and this introduction. So actually, a linear graph, am I audible or not? Let me see. Okay, so everything is working fine. So in a linear graph of the network comprise of the collection of the nodes and the vertices. Okay, vertices are the point and the branches. Okay, with the different node connected together by the branch, it is drawn by the representing the voltage and the current source by their internal impedance. Okay, the internal impedance of the ideal voltage is zero. So internal impedance of an ideal voltage is zero. Okay, keep in keep this in memory. So the internal voltage of that point is zero. Okay, let's move. Hence, it denoted a short circuit that of the ideal infinite. The short circuit of the ideal circuit has a infinite. Hence, the open circuit and the keeping all the nodes and branches of the network. Okay, graph whose branches carry an arrow to indicate the orientation referred as a indirect or the oriented graph, else they are referred as the undirected something. Okay, the connected graph is one in which there is one in which continuous path all the branches any of which may be traversed more than once. Okay, so in the so when we discuss about the graph whose branches are carried by the arrow indicate the orientation. So if the arrow indicate, it is directed and the oriented graph. Else if there is not an arrow or anything is given, then I refer as the undirected, and the graph is one in which there is a continuous path all the any of which may be traversed more than once. Okay, so which touch all the nodes. If a graph has n nodes, then this is ranked as n minus 1. Okay, the subgraph is the subset of the branches and the nodes of the graph. A subgraph is said to be a proper if it consists of strictly less than all the branches. Okay, so in this whole point we have to discuss the graph subgraph. Okay, and after that we move for the tree like structure. Okay, how the tree look likes. Okay, so tree in which trees actually we have to quickly recap is that a tree is a set of branches with the each node connected to the every other node directly or indirectly, such that the removal of any of the branches destroy the property. Okay, in other words, a tree of a graph is a subset of the branches such that all the graph nodes are connected by the branches but without forming a valid path. A tree actually, we can say, tree actually has n minus 1 branches where n is number of nodes and the branches of tree is referred as a twig. Okay, all the link combined together. Okay, So if a graph is not connected, then the set if a graph is not connected, then the set of tree ones are separate. Okay, as a forest. Okay, so we can see these are the structure network circuit like this one. Hmm, this is connected to arrow is defining the directness. Okay, so this is the tree. Twigs is like tiny of a tree. So one, two, three, and the link to the one, three, four. Okay, these are the linkers. So in this we have see the impedance matrix. Okay, impedance matrix. What is this? How we find this impedance matrix? The fundamental cut set of the matrix. How the cut section and how we find the all the things. Circuit matrix and the set matrix. Okay, enter the important formulas for this one is this one, and so identify the graph as to show, and after that this is the network branches. We have to move for the next thing is that next chapter is that nodal and mesh analysis. So nodal and mesh analysis. So first of all we see the nodal and the mesh analysis. So in this chapter we have to discuss the topic of the Kirchhoff's law, voltage and Kirchhoff's current law, and the parallel series combination. So these are the important one. As we know, Kirchhoff circuit law, Kirchhoff voltage law, Kirchhoff current laws. Okay. So in what we see in the Kirchhoff circuit law, we can govern the conservation of the charge and energy in an electrical system. Okay. So there are two Kirchhoff circuits, basically known as Kirchhoff voltage and Kirchhoff current law. So according to the voltage law, the algebraic sum of all branches voltage across the any closed loop of a network is a zero. So algebraic sum of the all branches around a closed loop is a network is equal to zero at the instance of time. In another word, we can say directed sum of the electrical potential difference around any of the closed circuit is equal to zero. But in the Kirchhoff's current law, we can say that Kirchhoff's current law state that at any junction in electrical circuit, the sum of the flowing into the node n is equal to sum of the current flowing into the node is equal to the sum of the current flowing out of the node is algebraic sum of the sum of all incoming current is equal to sum of all outgoing current. Okay, so this is one, and the net conductor is zero. In another word, we can say the sum of the current entering the junction is thus is equal to the leaving the junction. This implies the current conservation, no loss in the current. Okay, okay. We have two types of this network: is series parallel and the series parallel both network. Only we can see the both combination. In series, we simply see that R1, R2, R3, R4 are connected, and we have to find the R equivalent. Okay, so what we say, the R equivalent is equal to R1 plus R2 plus Rn. Okay, and the resistor in parallel, we can see all these are in parallel. Okay, and the R equivalent will get. So for the R equivalent, we can find by this equation, by R equivalent is equal to 1 by R1, R2 and R3. So what if the capacitor in this series, what if a capacitor in this series? So we have n capacitor. Okay, if they are connected in this series form, so the equivalent of this one is equal to 1 by C equivalent is equal to 1 by C1, C2, like this one. Okay, if capacitor is connected in parallel form, okay, so C equivalent changes, so it become 1 2 3 4 5 like this one. Okay, in parallel we simply add like this one. Okay, and then we have to see inductors. Inductors in a series, we follow the same property like a resistance. All the independent are pluses, and the in parallel we have two like this one, 1 by L1 by L2. Okay, so L equivalent is 0. And the source transformation, how we source transform, after that a network 1 to pi transformation, a T or pi transformation, how we do type of pi transformation. Okay, then after that mesh analysis, how we do mesh analysis. After nodal analysis, how we do the important formulas we have discussed. For pi transformation, we simply write this one, mesh analysis and nodal analysis, look like this one. And the chapter is a network theorem. In chapter 3 we have this network theorem, in which we have see the superposition theorem and the Thevenin theorem. So superposition theorem and Thevenin theorem. So this is not that much important right now. So from delta to y transformation. For this equation, how we find R1? R1 is equal because of this RB, RC, and because of the side of nodes, and then we add R, B, C. Okay. For R2, we can write RC plus RA and all of this. For this one, we write RA or RB. Okay. So how we find? Okay. You find the R1, R2, R3. How we find this equation like RA, RB, and RC. Okay, so we have formula for when we have to find. Okay, let me erase this one. So when we have to find RA, so how we do? So we see what we see R2 and R3. Okay, by this one. So R2 into R3 plus R2 plus R3. Okay, and we see the multiplication divided by the this one. Similarly, for we have to find this one. So what we do for RC, we have C the equation like R1 plus R1 plus R2. Okay, plus R1 into R2. Okay, divided by the value here R3. Okay, R1 R2 plus this one. We see R3 is equal to R plus. Okay, to understand the basic formulas. Delta Y transformation. Okay, steady state sinusoidal analysis. We know the wave are in the form of Vt is equal to V sin omega t plus this one. The frequency is 1 by t, and t we can also add omega by 2 pi. Okay, omega by 2 pi. Okay, where sinusoidal steady state analysis on time domain is equal to like this one. P is equal to so so time analysis formulas of the values. What is phasors? Impedance, phase angles, impedance, all the things. Important formula we have to keep in mind our for the series RC steady state analysis. We have see the formula of V is equal to IR. So R equivalent is equal to because I in which we have to write the equivalent impedance. Okay, for the RC circuit. R for the this one and C capacitance omega C whole square. Okay, sin 1 theta. When you have to write the I equation, so simply V sin omega t is equal to this one and the equivalent for the RL we simply omega L. Okay, for the RLC circuits, what we will do first order RC or RL circuit. These are the unit function. After that, delayed unit function, unit impulse function, unit ramp function. Ramp function we can see unit function in which the t less than is equal to 0 having the value of 0 at t greater than 0 as 1 less than 0. Okay, in delayed we have see at a specific time delayed mean in which we simply shift delayed mean this like this one. Okay. So t less than t naught is equal to 0. Okay, and for the value t greater than this one we simply say 1. Okay, for the ramp function less than 0 we can say 0. After that value become 1, not 1 like changing with t. The series RLC circuit, how we look at RLC circuit, how the series RLC circuit is analysis. In parallel RLC circuit, how it's look like. Okay, so quality factor for a maximum energy stored by the energy dissipated per cycle. So in Laplace transform, the common will simply this one is equal to 1 by s. If e the power something, so we can simply write it 1 minus s minus a. For the Laplacian transform of the s sin omega and cos sin omega, simply we can omega s square plus omega square. Or for the cos, we write s. Okay. T the power n, anything of t the power n is equal to n factorial by s the power n plus 1. And Laplacian transform, this is the Laplacian transform of all this one. Laplacian transform is simply we can write as minus of infinity to this one f of t e the power minus s of t dt. So u of dt is a unit function, so value will become 1 e the power something. The Laplace transform of the difference operation. Two port system, hybrid parameters. Okay, two port system, hybrid parameters, all these things. Okay, we have interconnection, two port conditions. What are the conditions for two ports? Series connection, important formulas we have. In chapter 7, we have to discuss the state equation for the network. State equation in which analysis important things were. Now after that, EDC, electronic devices. So in semiconductor physics. So from chapter 8, we have to discuss the next part. So okay, in the next session we have to discuss the electronic devices, that is EDC. Okay. For till now, we have to say